Hello, the Nature Conservancy would like to welcome you to this virtual Field to Lake Twilight event. One of the main topics for the program is drainage water management, so we'd like to start off with Bruce Clevenger giving us the golden rule of drainage.
So there is a golden rule of agricultural drainage, and the quote originally came from Wayne Skaggs, originally from Kentucky, studied at Purdue, and was a extension specialist in North Carolina on drainage for years. And his golden rule that he developed was really drain the land only what's necessary for trafficability and crop production, and not a drop more. So drainage water management can play a part in conserving that water and not letting those precious drops of water that we need for crop production to leave the farm.
A big thanks to Paulding Soil and Water Conservation District, Paulding OSU Extension, and the Cover Crop Champions for helping to plan the program. We'll have 3 stations. At the first station, Bruce Clevenger will be talking about drainage water management on the Singer farm. Then we'll move to Don Johnson's farm, where he will be speaking with Sarah Noggle about how they use those structures on his farm. And lastly, we'll talk with Ron Snyder. He's a cover crop champion who's building soil health on his farm. Let's get started right away with Bruce.
So across the Midwest, we do rely heavily on subsurface drainage. And when we talk about subsurface drainage, often we're referring to corrugated plastic tubing. A lot of times it's referred to tile, which refers to clay tile of years ago, but now all the installation is done with corrugated plastic tubing. This plastic tubing would have slots in it that just allow that gravitational water to move from the soil profile into our subsurface drainage system. And so why is it so important to have subsurface tile? There's really 3 benefits that I can see in the subsurface drainage system. We increase the number of days of field work by having a drainage system in a crop field. We lengthen the number of days in the spring, and also we have more days in the fall during harvest for field operations that has safe trafficability with farm equipment. The second advantage would be that we also see a crop response. We improve that crop yield by really removing the periods of time where we have prolonged excess water levels, really damaging sometimes the root systems of our crops. And so that's our second advantage. And the third advantage would be really a soil erosion reduction. When we have a subsurface drainage system, we are making space in the soil profile for water to infiltrate at the soil surface rather than just running off the surface. If more of the water was running across the soil surface, it would carry with it soil particles, and that would increase soil erosion. So by having a subsurface drainage system, we're allowing the opportunity for water infiltration and that water to move through the soil profile. So the essence of drainage is really profound across the Midwest. A large footprint of production agriculture has installed a subsurface drainage system. So when we talk about drainage water management, it gives us a great opportunity because a lot of that infrastructure is already in place in our major crop production areas. And so by adding a management device like a structure is going to give us some opportunities to look at. And when we look at the effects of drainage water management and managing the outlet of that farm, we're looking at reducing the total water on an annual basis effectively that would leave the farm. And that may alarm people, but really it's at the time of the year when we don't need that water. And this is mainly after the growing season is complete, harvest is done. We can conserve that water in the non-growing season and get a reduction in that total water volume that is contributing to the watershed. And secondly, with that water that is leaving the fields, often there are soluble nutrients that are carried with that volume of water that if we can retain that water on the farm, we are proportionally reducing those soluble nutrients from leaving the farm, entering streams, and essentially getting into lakes and bodies of water. So we're very confident that this management device can help us in that regards. Then there's the opportunity for a yield response. So during the growing season, when we have the ability to conserve really precious water that we need for crop production, we have the potential to boost our yields by having that water that is conserved, that would otherwise been gravitationally sent down through the tile and out the streams, and providing that water to the field crops for yield improvements. So those three areas are very helpful when considering a drainage water management system. In fact, the amount of water that we drain from a field is actually a fairly small amount on the total proportion of the total water in a field. We really want the majority of our water in the soil profile to be plant available, which means it's going to be held on by the soil particles, the organic matter, and that water there is not going to be pulled by gravity out of the field to our tile, but it's going to be held in place by our soil and our organic matter. And that water itself can contribute to yield. But sometimes we have extra water that comes through the cropping system in the summertime, and that otherwise that would leave the field. If we can conserve that water, we can see a potential there for a yield advantage. So because there's a wide use of subsurface drainage systems, we have an opportunity to have a wide adoption for drainage water management across the Midwest. Specifically in Ohio, it's estimated that 2.2 million cropland acres are very suitable to retrofit the subsurface drainage system to have a control structure in place here in Ohio. And yet we're only fourth from the top of the list. There are 3 other states that have more acres than Ohio that are adaptable to drainage water management. We think of, where does this happen in the Midwest? North Dakota all the way down to Missouri, from Iowa all the way over to Ohio. These are prime production areas of the Corn Belt, soybean region, that there is much acreage potential for adapting drainage water management to it. So essentially what we have here today at this farm is a control structure that is about 47 inches deep from the top of the structure at the surface that we see here to the bottom of the box. There's about 47 total inches of depth to that structure. The reason it's so deep is because that is the depth at which this main is delivering the water from the field. My cutoff model here is a tabletop, so it's just cut short from the top to bottom so that we can get a good idea of what it looks like under the ground. But in this structure today, because drainage water management has been applied over the last couple of months, we have had some rain events that have been conserved. There is 20 inches of water being conserved behind these boards today that is available for this crop to respond from. So we talk about water running downhill, but how does that work when we conserve water deep into the soil profile? How does that water essentially go uphill to benefit the crop? And that happens because we have capillary rise. Capillary rise is those small micro spaces in the soil profile. And when we have a medium to fine textured soil, we have a higher rate of capillary rise. So we have a pool of water in the lower profile that actually, by capillary action, will moisten the soil above it and then into that root zone, and that interaction between the crop roots and that capillary rise of water will give us the yield response, or the opportunity for yield response, if we can conserve that water. And so that is a very essential part of why that conservation of water is important. And so as the crop demands more water, we would expect that conserved amount of water to slowly shrink, and then potentially the next rain event would also recharge that conserved water level during the growing season, and we would be able to manage that all the way through up till harvest. So essentially some of the components of the structure, this structure has a much taller management tool to reach the lower boards than my shorter one here. So we need a larger tool to reach the bottom board so we can manage that bottom elevation. Each of these boxes have boards essentially that will be placed on top of each other that will artificially raise the outlet on that control structure for the system. One thing that we do not do with drainage water management is what people sometimes refer to as plugging the tile. Plugging the tile would essentially describe that we've eliminated the outlet or the ability for that water to flow freely out by gravity. By managing the elevation of the outlet, we are stacking boards up taller and taller and conserving water, but there is always opportunity. If this farm were to be inundated with water, the water would still flow through the profile and still run over that top board. So the height from the soil surface to that water level during the growing season may be as much as 24 inches during the growing season, so that we still have aerated soils for the roots to thrive in, but at the same time we're providing that capillary moisture from below from the water that we have conserved in that subsurface drainage system. And that elevation will change as we go through the calendar year outside of the growing season. So as we get closer to harvest, this control structure would be managed, and we may end up at harvest, if it's a rainier period of time, we may pull all the boards and remove that extra water out of the system to get an increased trafficability. But once harvest is over, the control structure boards would be replaced into the box, and we would elevate or begin to conserve that water in the non-growing season. The winter elevation may be recommended higher than the summertime elevation. Here in Ohio, we may have that elevation as close to the soil surface as 12 to 18 inches below the soil surface. So those boards are stacked a little bit higher during the non-growing season compared to the growing season, just to allow for an additional volume of water to be conserved and retained on the farm during the non-growing season. Let's pass through the winter time and come around to the spring. We're maybe 2 to 4 weeks ahead of planting. Well, our recommendations would be to pull the boards, maybe even staggered, so many a week, and then maybe pull them, the additional ones, a week later. Or we could flush the system, and sometimes there is sediment that accumulates in subsurface tile. That can be flushed out in that spring removal of the boards. But essentially we're trying to get ready for spring planting and spring field operations. But pulling the boards doesn't mean we automatically then have trafficability, because we need a little bit of spring evaporation to get the soil surface to the point of trafficability. Subsurface drainage doesn't automatically equal trafficability. We can use subsurface drainage plus then spring evaporation to get to the point where we have trafficability. So 2 to 4 weeks prior to a normal planting date would be ideal to get that field ready for spring operations. And then once spring operations are completed, we would then begin to replace those boards to elevate that water level to maybe that 24 inches below the soil surface. Or if our management is intense, or we're wanting and willing to have more management responsibility, we could even elevate that a little bit even higher during the growing season if we're willing to manage it and be ready to remove boards if we know we're going to be in a period of wet conditions, and we certainly want to protect that growing crop. So some of the yield responses that have been seen across Ohio and other Midwest states on what would we expect as a percentage of yield increase. And this would go for both corn and soybeans. The data suggests somewhere between 3 and 5%, maybe upwards of 7% a yield response on some years. Because in a drainage water management system, we're not adding any water to a field for subsurface irrigation. So for example, the crop year 2012, when we remained dry throughout the summer, we may have our boards in place, but if drought conditions persist, we're not going to be able to conserve or to charge that water in storage because we're just not getting it from precipitation. So some years we would not expect a yield response just because we are in a drainage water management system. But in years like this year, 2020, where we have had occasional periods of rainfall, but really stretches of dry period where that soil cracks and we see drought or dry conditions at the surface, there's an opportunity then for that next rain event. When it comes, it can be conserved in the subsurface drainage system. An example of needing a structure or maybe electing to establish a drainage water management system would be if you've ever been a farmer and you've been waiting for that next rain. Field conditions are very dry. You see the soil cracking. And it's been several weeks since that last rain event. And then all of a sudden, the forecast looks good, and you do in fact get that rain. But yet when it starts to rain, and by the end of the day, what you're observing is your tile are running, and that rainfall precipitation that you've been waiting for your crop to respond to now is leaving the farm through the subsurface drainage system. Having a control structure in place gives you the opportunity to conserve that water, keep it in the field for a crop response, but additionally, it's also reducing our nutrient exporting of those soluble nutrients. So what do we expect from water quality response? Typically, if a drainage water system on an annual basis could reduce the total volume of water that leaves the farm by either 40 or 60% of the total volume, proportionally, we're going to reduce the soluble nutrient amounts by that same proportion. So if we're able to reduce the water volume leaving the farm by 50%, we are then confident, and we have evidence that says that we can reduce the annual loading of that soluble nutrient also by that 50% reduction in that load that otherwise would leave that farm. So there's opportunities for crop improvements, and there's certainly opportunities for water quality improvements. And I think year over year, a farmer is going to see consistently more of a water quality improvement, more so than a year over year consistent response in yield response, in a yield improvement. And so this is one of those practices that we can implement to play our own part in the solution for reducing nutrient loads to our lakes, rivers, and streams.
What a great overview from Bruce about drainage water management structures and the details of using those structures on your farm. While we were there, we were able to hear from Defiance County farmer Dan Singer giving us his thoughts on the structures.
Everybody knows that tile pay for themselves. If on the ground, they really help. This water structure just helps pay for it a little sooner because you can control the water. If you're getting ready to plant, you open the structure up, get the field dried out, plant the field, and then when you got everything planted and it looks like it's going to stay dry, close it up, you hold that water in there, and through the summer it really helps the crop by having that water held in the field. And then in the fall you open it up, let the water out so you can harvest. And I just really think that those structures are really great. They really help pay for them tile.
Before we leave, let's zoom in a little bit closer on the drainage water management model.
So control structures often have a designated bottom board. It just has extra seals so that that bottom board is properly placed, and so we have a good solid board at the bottom for managing that water. Each additional board would then also have seals and then placed on top of each other to again raise that outlet elevation. So again, we're managing more water being held in the field by each board that's being added to the structure. The tool then has two parts to it. We certainly have the part that would grab a hold of each board and pull it out, but then it also has a push section or a push board to push those boards back down in there so that they slide in and out. Structures ought to be maintained on an annual basis as well with some silicone lubricant, just so that these boards slide and the rubber seals stay soft. And so a lot of the manufacturers will provide a recommended silicone lubricant or grease that goes along with these control structures. During installation, it's very important that the bottom of the hole where this structure is placed is undisturbed or remains very solid. We do not want this structure to be settling after installation. We don't want it to sink. And we also want to use proper fittings when attaching corrugated plastic tubing to any drainage system. When we install a control structure, it's recommended that a 20-foot non-perforated section of pipe is joined to the structure with proper fittings so that we are reducing the risk of seepage, because if the structure is holding head pressure, we want to have solid piping 20 feet away from the structure to prevent any water to bypass the structure. Also on the downstream side, we recommend 10 to 20 feet also of solid non-perforated pipe, either PVC or double wall corrugated plastic tubing, because sometimes depending on where the structure is placed, there may be a creek or a ditch that water elevation increases that could bring water pressure back from the downstream side of the structure as well. So follow the manufacturer's recommendations on installation, and we'll have a greater success of these structures performing in the way that they're designed to.
If you have any questions for Bruce, he can be reached at the Defiance County Extension office. Next, we're going to move to Don Johnson's farm. He's talking with Sarah Noggle, Paulding County OSU Extension agent, about the drainage water management structures on his farm. Please bear with us through this section as we move to 3 different structures. We are still very new at capturing these types of videos.
Hi, my name is Sarah Noggle. I'm the Extension educator here in Paulding County. We're working on a field day on drainage control structures with our partnership with the Paulding Soil and Water, the Nature Conservancy, our CAT board, and our local farmers here in Paulding County. We're excited to have with us today Don Johnson. Don is one of our local farmers here in Oakwood, and we're going to talk a little bit today about our drainage control structures. So Don, share a little bit about your farming practices with us in the recent years and what led you into these drainage control boxes.
When we used to get it, before we did no-tilling, and I think I had this before I started no-tilling much, if we got a ½ inch of rain, you had cracks in the ground, because I've got heavier ground here, it would run right down in the tile and run off. This, and the no-tilling help, plus this right here, will capture the water, at least in the tile, and the roots do have a chance. I don't raise corn anymore, and if I probably did, corn roots I think go deeper than beans and would really help. But I still think, my wife was riding a combine with me 2-3 years ago, and she says, why are all these beans so much taller over the tile? I said, well, and it was dry. It wasn't because it was wet, because there was moisture, and I'm positive the roots did get down to the water in the tile.
So Don, I know you've had these drainage control structures for a few years. About how many years have you had them, and what led you to starting to use them?
I don't know. I got everything's tiled now. I had everything tiled at 40 feet. Then I bought this in my grandfather's place, and I bought this, and it had tile about every 20 feet, but they was old, so I started looking at those, and we just said, hey, with every 25 foot, I think we put them in 25 here, and we just retiled everything. And then at that time, but I had them in at home for, I'm guessing 15 years at least.
So quite a bit of time.
Oh yeah.
And so we want to talk a little bit about the different companies that make these and the different structures. So share with me, you've got a few different kinds on your farm.
I got 3 Haviland drain companies, 3 from Haviland. One of our firemen's a manager up at production manager at Haviland, and he went, oh, you got to try them. Well, I did. And I like to buy local if I can, but the rest of them came agri-drain out of Iowa. If you go to buy, the first ones I bought, I just ordered them myself and they delivered them. Don't do that. Have your tile person order them because you'll save like 30%. And that's a big savings. And it was cheaper then. But these right here, Havilands, they came out. I had a little issue with them. I could show you to them. They say that the tile don't shrink together. Or maybe if I was a lot stronger, I wouldn't have any trouble pulling these up. But I did. And so I took a board and well, he helped me too. Ed, somebody's his name, from Havilands. And we put it in there. Well, that didn't last, so I made a bigger one this year, and I can get it. Now, this one always worked good. It was the next one up there I had the trouble with. And then on the last one is an agri-drain, but they got posts across there holding them better, which is good. I think Ken at Water and Service there, but I still got the first one through Paulding Soil and Water, and that's been Dick Parrish and I was the first two to get them. That's been, who was the guy before you?
Jim Lobshire.
Jim, he's the guy. Yeah.
Okay.
Jim.
So, taking care of these and maintaining them, I know, we hear back and forth that sometimes it's the maintenance of them, sometimes it's the, opening those boxes. Talk about the depth that you leave these boxes at throughout the year, and how do you change the depth of those?
You just take a rod, and I got 5 boards in mine, and you just pull them up and down like this right here and this right here. Every spring, I'll pull the boards all out, and I'll take grease and I'll grease the sides so they move up and down. Now maybe if there's a bigger guy and a lot stronger, you wouldn't have as much trouble sometimes as I do. But the only ones I ever had trouble with is this one and one other one. I think I got a problem solved because where these go in, either they didn't get them quite straight at Havilands. Anyways, I got them pushed out. And as for that, I can't see any difference, one against the other.
So do you think with this conservation practice that it's helping with, the different conservation? I know you're a no-till farmer, and, holding that water is sometimes key in our heavy clay soils. You're either really wet or you're really dry, I feel like
That's
sometimes.
Right. Well, I'm positive it holds, you know what I'm saying? It's just no doubt about it. Yeah. And I'm positive they leak a little, but still it's going to take a long time. If I can have, this much water and this only much this from the top, once I don't usually close them down after I get my crops planted.
Okay, so
Yeah.
you leave them open once your crops are planted then? Or you leave them closed once your crops
You're right,
are planted?
at least 3 boards, and now
Okay.
some people base corn. I talked to one of the first guys, Tim Slaughter. He was one of the first ones to ever get him. He was on the board at that time, and he said, well, he had corn. He said, I got mine completely shut now. Did he shut all the boards? I don't know, but that's been 20 years.
20 years ago.
I'm just guessing. I don't know, but I've had them quite a while. I never thought to look and see, but I got lucky. The government paid for all of them except 4.
So it's a cost share type of program, and I
Yes,
know we
yeah.
have different programs out there currently that will cost share some of those. Talk about the installation. What did that take? Whether you said you would recommend going with your tile company, so they would order those.
Yes, right.
That process, did you have those engineered by Soil and Water or NRCS?
Yes, they'll come out. They checked all this. They said I needed like a 5-foot one here, a 6-foot one there, and that. I like to keep them a little lower than so you can mow over top of them easy. I used to have a bird box at each one of these. Well, then I got one of these sickle mowers, and so now I can just lift up high enough, and I got time. I tried to keep stuff mowed up pretty good.
And I thought it was interesting that you painted the top so you can see them. I thought that was innovative and creative, and I think a lot of people do that when you're out there mowing and keep them mowed around them.
Yeah.
What other maintenance once they're installed, other than greasing them and making sure those are there?
That's all I ever do.
Okay.
That's all I've ever done. I've never lost any lids. I keep a little hook on them, and just for that. But like I said, like local. But I had issues, and I could show it. But I think I eliminated the problem now. And if you got somebody 6 foot big and strong and young, probably bring them up too a lot easier than I can sometimes. So.
Looking at the lay of our land here in Paulding County, we're fairly flat. I would say our slope is not great. When you talk about how many acres does one of the drainage control structures hold?
This one right here is 8 inch, and it'll do. I got 20 acres running into this one, and the next one up here, this is like 43 acres, and there's 23 in that one. Then the backfield is 30, and I got 1 into that.
And that's pretty typical. You know, sometimes they say on your flatter ground you can hold more if you have a little bit more slope. You know, that changes those drainage control structures and that engineering. But I think partnering with, you know, whoever you're working with, whether it's your tile company, your soil and water, NRCS, just to get the correct number of those and where they can hold, and looking at, you know, your tiling patterns.
Yeah.
So I know you shared with us at the last box a little bit of things that you had difficulty with, and this is one of the ones that, you know, you retrofitted some of this. This is one of your older drains. Share with us what you did to this box and what was required.
Haviland came out last year, and he 3 or 4 times, and they treated me good. I ain't knocking one bit. And we had to take a board and put in between here and there. We took a wood first to fit. Then they got a piece of plastic we put down there. Well, this spring that didn't work. So I had some plastic at home, was 1 inch thick and 6 inches wide. I cut it and I got it just so it fits right here, and I took a sledge, and the ground was soft, and I drove it down there and I spread that apart.
Okay, so we're going to talk about the second type of drain that you have, and you have an agri drain. So share a little bit about the differences between the other box and this one. And
Agri drain has basically got the same thing. They just pull up and down. In fact, I think they pull a little easier, but they got aluminum bars, or I think it's aluminum, across holding this spread apart.
So, you know, just the same thing, and you can see the bars, the metal bars in this one, holding that apart and looking at the difference. A little bit different, you know, structure to that,
yeah.
But definitely still holding the water and doing its job in that whole conservation practice, and using that water different times of the year when you need it. And
yes. The winter, I guess, I might as well be honest, I guess you're supposed to have them closed. I don't. Maybe I might have one board, not a whole lot, but the rest of the time, when spring comes, I just leave them like that. I'll probably do my maintenance when I have plenty of time in the spring, can't do nothing else. Then as soon as the crop gets up, then I'll come back and I'll shut them 3, 4 boards at the most. But that's, you know, these boards are anywhere from like this to like 6 inches wide. So you pick your poison of how you want to, however many you want, and do it. But so
3 or 4 boards deep, and that's where you
and
keep
each
them?
person's different. If you had good sandy ground, maybe you'd want more. You know, I mean, you got to learn yourself. But I just come and let it go. And now this fall, when we get ready to combine, I'll probably pull them up in case we do get a rain. The water's done its good out there, and we want to get rid of it so we can harvest. So.
Okay. Well, I appreciate your time today, Don.
Okay, no problem. Hope I can help somebody. That's all I'm after, trying to help. That's all you get out of life, is helping somebody.
We've heard a lot about drainage water management on the farm. And while we know this is important, we also know that building your soil health is very important. Ron Snyder, a cover crop champion, is going to talk to us about how he does that in his farm.
I'm Ron Snyder, small farmer from Wood County, in between Pemberville, Bowling Green, Ohio. About 10 years ago, good 10 years ago, 11, I started noticing things on my farm that were not conducive to agriculture, let's say. Could not get water through the ground. And everybody said, tile it, tile it, tile it. Well, when you can't get a half-inch rain through the ground to get to the tile, you've got a problem. And things just kept going backwards and backwards. And then finally I started on this cover crop program, so to speak. The more I started working with the cover crop program and switching to complete no-till, things started to get better. Now the first 3 years, trying to change the soils over, that was a challenge, quite out flat challenging. Third year was my worst year. I could see things just struggling, trying to get going. After the third year, about the fourth year, and then in the fifth year, you could really start to see a difference. The water would start to go through the ground. We could get rains, and it would just keep going through the ground a little bit. Okay, then 2 years ago now, then I tiled my farm, and hey, guess what? Things are starting to work a little better again because we can get the water to the tile. If you can't get the water to the tile, you've got a major problem. And So that's kind of what I did, and that's kind of my story where I'm coming from here, is I started on the cover crops. And, you know, for telling somebody to start out on the cover crops, right now there is so many different avenues that people try to tell you to go. Okay, you need to work on your compaction. You need to get your microbiome going. You need to use this cover crop, the next cover crop. And, you know, when I've talked to people, I said, let's break this down and forget all the baloney. And you got two concepts that you're after. The first concept is you want to promote arbuscular mycorrhizae fungi. The next thing you want to do is to promote your microbiome, or all your microbiology in the soil. Those are the two main ingredients. Now, we can do this by using cover crops. And I know a lot of people get hung up, well, we need this cover crop, we need that cover crop, another cover crop, so forth and so on. And I've seen where a lot of people get hung up on this, and well, I'm not quite sure what to plant. I think we're looking at it a little bit incorrectly there. The trick is, let's plant something. And let's start out by kind of making things, so to speak, simple. If you're going to go to corn, let's try to get some oats in, maybe with a winter pea and some radish. Just real simple. The oats winter kills, the radish winter kills. The peas may or may not winter kill, but they are not an issue coming through the winter. You can take those out relatively easy with no problem whatsoever. And if you're going to go to soybeans, let's use cereal rye. Those are some very basic things that you can do. And when you start doing this, and you've got that living plant, what you're producing is a root structure in the ground that creates aggregate stability. Now, you heard me earlier talk about that I couldn't get water through my ground or my soil. My aggregate stability was next to nothing. It was either a concrete block or dust, one of the two. That was my soil type. I taught construction for 30 years. One time I went out, I took a spade and I dug in the field and I pulled up a block of soil. And quite honestly, there was more pore space in concrete than there was in the soil. That lets you have an idea of how tight things were. So with using the cover crops and getting things going, and it takes a while. It's not, I'm not there yet. I've been at it for over 10 years. I'm not where I want to be, but we're moving in the right direction and things are a lot better. But you're trying to create that aggregate stability. And those are like all the little clumps of soil hung around the roots. And you have to start understanding, and this has been a real journey for me, but you have to start understanding how soil works. And soil works with the plants. You got to have plants going all the time, or as much as possible. And if you have this going on, you got your aggregate stability is constantly being changed and moved and critiqued around. Once you create the aggregate stability in the soils, you create pore space to go through between the aggregates. Once you have the aggregates, then the water moves through the soil a little easier, and then everything just starts to snowball, and you go deeper and deeper and deeper into this program that or this journey, I should say, that I've been on. I have started reading some books. I listen to a tremendous amount of podcasts. I've learned a tremendous amount that we are not being told, or we don't understand. as a farmer, I always thought I knew something. Well, I knew my machinery, I knew my seed, I knew my chemicals, I knew all these things, and well, we just put it in the ground and everything's fine. No. I've totally changed my perspective. The machinery doesn't matter as long as it goes up and down the field. The seed kind does matter to some amount. I try to get as much treatment off of it as I possibly can. In the chemicals, cut back. In a soil health thing, there's 3 things that really deter good soil health. The number 1 thing is chemicals. Chemicals, insecticides, pesticides, herbicides. Those types of things have a tendency to kill your microbiome in the soil. The next worst thing that you can use, and I know I'm going to really rattle your chain on this one, but it is synthetic fertilizer. There's other ways to do this. The third thing, of course, is tillage. You want to minimize that, and that is the least of the 3 that is detrimental. So let's jump back, and I think it's pretty evident when I say the chemicals. I think every farmer really has a understanding of what the chemicals, even though there's a lot of debate, I guess is a good word, around glyphosate. It's probably a lesser harmful chemical than what we have been using in the past. And if we can rotate those chemicals, so to speak, a little bit and try to get different things in there. I do not use residuals anymore. They are gone. I take and I have a roller crimper on my planter. That's probably going to be changing, and I may be looking at purchasing a roller crimper on a 3-point. Rolling the crop down, creating a mat, so to speak, and eliminating herbicides, starting to eliminate them. The next thing, and I know this is the one that's really going to rattle your chain, like I said, is fertilizers, the synthetic fertilizers. Now, do I still use them? Yes. Do I use them like I used to? No. I think we all need to educate ourselves in how the soil works. At this point in time, I would strongly suggest that everybody check out Mulvaney from the University of Illinois on his nitrogen cycle and his potash cycle. That is a good place to start to look. He's very knowledgeable in these areas. I've kind of used some of his thoughts, and I do have a tester field. It's a small field where I do goofy things in, so to speak. But starting in 2011, I put on no phosphorus, no potash. I still have not put on phosphorus or potash to this date. My numbers on phosphorus and potash are not going down. They are going up. Not dramatically, but they are going up. And it gets back to the soil health again. When you start putting plants into the ground and you have this microbiome, so to speak, going, 40% of your organic material can be dead carcasses of microbiology. There's a whole bunch of things going on in the soil. So when you start having things like that happen, you have your earthworms come in, that's going to come down and take your straws and your leaves and this type of thing down. And you get this system working, yes, your numbers do start to go up. But you have to understand the system a little bit. And that's the part where I've been cutting back on fertilizers And we're going to take another step again this next year. It's little steps by little steps, but we're going to take another little step to move forward. And by doing this, your aggregates are also being formed by your microbiology. So if you're creating your soil structure is also being formed by the microbiology, it's a win-win situation. So then you get better infiltration. You get better infiltration, guess what? Your roots can go down better. Things just naturally start to work better. And they keep working their way down and down and down. And pretty soon you get a system that really works. So that's a little bit about soil aggregation. And I think that's very important to the drainage part of this.
Thank you so much to everyone who helped plan the program. A special thank you to the speakers and also to those of you who have tuned in to listen. If anyone has any questions for us or the presenters, please feel free to contact us. We would love to hear from you.